Hello, and welcome to this Radiant Vision Systems webinar. I would like to introduce today's presenter. With us today is Chris Williamson. Chris is the Regional Sales Manager at Radiant Vision Systems. Chris, welcome to today's event. And with that, I'd like to pass things along to you to get us started. So go right ahead.
Thank you, Katie, for the introduction, and thank you everyone for attending today. I'm excited to share a presentation about automated inspection and verification of backlit character, luminance, and color, and we're going to be focusing on the aerospace industry and some of the inspection challenges that we see in this space. Quick introduction of Radiant Vision Systems. We are a supplier of automated visual inspection solutions across a wide range of industries and applications. Today, we're going to be talking about the aerospace industry, but we also do provide solutions in the consumer electronics space, automotive, and more. And we really focus and excel in areas where light and color measurement are required. So looking at the agenda, I want to start by looking at overview and requirements of the industry as a whole. Really what is involved in inspecting and measuring, illuminated aircraft panels. I want to talk about some of the inspection challenges that these panels pose, what's currently being used, and then introduce a new inspection solution from Radiant that's really solving some of the challenges that I'll introduce. Looking at the market outlook, their aircraft cockpit panel lighting market is about 1.8, almost a 2 billion market worldwide, and it is forecasted to grow. Now, some of that growth is fueled by the adoption of new technology in the avionics industry. You heard the term glass cockpit, specifically for panel lighting like you see in this picture. We do see an increasing adoption to LEDs due to the lower power consumption. So there's a need, an increased need for testing. Saying there's growth in advancement and that technology. Also, there's a significant portion of retrofit and upgrades on current technology, and because panel lighting can be such a or is such a critical element to flight safety that there's a constant focus on maintaining current aircraft technology. So like to take a look at drivers and challenges, particularly around testing needs in the aerospace or avionics industry. And when we look at drivers, one of the big ones is advancements in avionics technology and systems. And like I mentioned in the previous slide, we do see a general movement from incandescent to LEDs. And really what this means is that we have to keep the same strict testing standards that we saw with old technology to ensure that new technology is meeting the same, if not more strict standards, right? Upgrades and retrofits of older aircraft. And this is actually a huge portion of the market. We need to ensure that new technology that we're putting into the aircraft, as well as replacement technology, is meeting the same testing requirements when they were originally put in the aircraft. And this comes down to a safety concern. This is why upgrade and retrofit is so important, because if a pilot can't easily identify what button they're supposed to press, if there's a defect in the technology and the lighting, that's a serious safety concern. So both with the advancements in avionics technology and upgrades and retrofits, we need to ensure that all of the new technology produced is conforming to regulatory standards. And some of the challenges to this, I'm going to talk a lot about it throughout this presentation, but we see a lot of customization and complexity of panel design for different aircraft types. You're going to hear me say it throughout the presentation, but this is really a low volume, high mix scenario. So while there might be a low volume of panels produced, the variability of those panels from aircraft to aircraft, from product to product, from program to program is quite significant. And this makes it very difficult when inspecting to, provide an automated process. And really until now, there hasn't been a efficient and cost-effective solution that can handle the wide range of panels that we might see. In the last slide, I talked about regulatory compliance being one of the drivers of testing needs in the avionics industry. And here's a couple of examples of the regulations that we see. So CNS, communication, navigation, surveillance, or air traffic management, and some of the specifications associated around NVIS compliance. In Europe, there's the European Aviation Safety Agency and its associated specifications. Here in the United States, we mostly deal with MIL DT-7788, or you'll just hear, MIL 7788. This is a military standard. This is what I'm most familiar with, and what most of our customers in the United States are working with. But there are other specifications from the SAE, from the Department of Defense, that all deal with very, very similar regulations for both the commercial as well as private aircraft. Uh, Across all of these standards, there's definitely a couple of, not a couple, they're pretty much built on, some of the same measurement requirements that I'll go through. The big one is going to be luminance or brightness, right? And this is primarily focused on, is an icon bright enough for a pilot to see and to easily see, right? Is They want to be able to make sure that they're pressing the right button. That is, critical and is certainly a safety concern. Is the icon too bright, right, to potentially be a distraction to the pilot, or to confuse the pilot? And again, that's another safety concern. One of the primary reasons that we see a lot of these standards being written around, or very strict standards written around these lighting systems. And then contrast is related to brightness, but this is really comes down to readability. And this is uh, the backlit icon, can the pilot distinguish it from another icon? Can they determine that they are correcting the correct pressing the correct button? You can imagine that this is a huge safety concern, right? And it could be potentially disastrous if they are pressing the wrong button because they can't actually read it. Uh, Aircraft, just like anything else, aren't only flown at night in nighting conditions, or conditions favorable to lighting systems. So there are strict standards on being able to read the button even in, bright sunlight conditions. There's also a need to measure color, and this is also a safety concern. So let's take a look at an example. You can see on this panel on the left side where there's some red icons, a set of red icons on top, and a set of amber or yellow icons down below. And if you look in the middle, there's actually what looks like a little bit of blurring, where there might be some amber in the red, some red in the amber. And you can imagine, if the pilot is looking at this and he or she expects the red icon to be red and it's actually amber, or the amber icon to be amber and it's actually red, they might not be able to easily identify which switch they want to press, or which button they want to press. So that can be a concern. Also, for NVIS requirements, there are, requirements when using a external device, right? And can your measurement system, or can your sensor pick up on the right color? So we need to make sure that all of those icons are the right color to be compliant with NVIS. Another thing that all of the, a majority of the standards, or all the standards, have in common is how the brightness and color actually needs to be measured. And if you've been in this industry or have done testing in this space, you probably recognize this diagram. It outlines the areas on each character, or each number and each letter, that actually need to be measured. Sometimes you'll hear the mill testing as like the mill 3-point test, right? And that's because 3 points need to be measured on each character or letter. And then the average of these 3 points taken, as well as min max and different statistics. Uh, this testing was written primarily around when spot meters, and when I say spot meter, I mean a system that just measures the luminance and color at one single spot over a particular aperture, when that was the only solution to measure the luminance and color. So the idea being that an operator would align that spot meter, the aperture on that spot meter, to the 3 points on the character and letter, and perform a measurement there, and then take statistics from this. This is still how measurements are done, and all of the regulations, for the most part, require to follow the same process. So now I'd like to talk a little bit about some of the challenges for inspecting and measuring these icons. So one, probably the biggest that we'll talk about is variation among different panel layouts and sizes. We see a lot of variation in fonts and languages. Uh, Oftentimes, multiple measurements are needed or multiple metrology systems, and the process is still very manual. And that'll be a recurring theme that you'll see is it can take a long time because it is very manual, and there's very little tolerance for misalignment. It's not very robust to human error, and all of this really results in low throughput and long measurement times. So diving into a little bit more detail on the first measurement challenge, panel and layout variation. This is probably the biggest challenge and the biggest reason for inefficiencies in the current inspection process. You heard me say it before, and you're going to hear me say it again. Low volume, high mix. And what this means is that while there isn't a high volume necessarily in many cases of panel throughput, the panel is changing constantly. And so you could, and through one and single inspection point, you could have to measure 5, 10, 15, even 20 different panels on a particular day. You can see how this would pose a challenge when designing an inspection system. You can design a great inspection system that automates the process for one panel, that places the 3 points great. You save that as a template. However, the next, after 5 measurements, you might have a new panel that poses a new channel, or that poses a new challenge. Related to the first measurement challenge, on the single panel, there's a lot of variation. We can see multiple fonts, languages, we can see different unique shapes and symbols. And oftentimes, with traditional inspection systems, each of these requires a unique training that can be very cumbersome and time consuming when you start calculating all the different training models that you might need. There's a lot of different measurement parameters that are required when inspecting, and the regulations are pretty clear on requiring many of these. Of course, it's specific to the project, but for the most part, you're going to have to measure the luminance, including the brightness, the minimum and maximum brightness, light leakage. You're going to have to look at the chromaticity, the contrast, the sunlight readability, and then also ensure that there are no significant defects, or the position and orientation of the character is right. And all of this is done with uh, character verification, or making sure that the right character is there. And you'll hear me throughout the presentation refer to this as OCR, optical character recognition, or OCB, optical character verification. Another challenge is that typically, to get a complete inspection, multiple metrology systems are needed. And for each of the different requirements, uh, sometimes, two different devices are needed. So let's take a look at an example. So for optical, or for character identification and verification, or OCR, you need an image of the system. So sometimes a machine vision camera with OCR software is used for this. Really, to date, there is no photometer, or imaging photometer, imaging colorimeter that has this capability. So for one aspect of the inspection, you need a machine vision camera. And then for luminance and color inspection, or your photometric results, you need either a photometer, colorimeter, spot meter, or a spectrometer. Another challenge is that current methods are pretty inefficient. So you can see this image to the right. This is an example of a setup. So what you have is a spot meter that's on a stage. And while it looks like it might be set up to be automated, it's really not. And that's because, going back to our first challenge with panel variation, it's very difficult to design a fully automated system with a spot meter. So the spot meter is typically placed on an XYZ stage, and it's manually moved by the operator to measure at those 3 different points that we saw before. The operator is typically looking through like an alignment piece, and then when they reach a measurement point, they either record a measurement, or use a foot pedal to capture an acquisition and record a value. The issue with this is that it's slow and inefficient, right? So the spot meter or photometer must be positioned individually at 3 points. Uh, you know, you could taking a look at some of the panel examples that we've shown already. If you have to measure 3 points on each panel and you have to measure every single character, you can see how very, very quickly this can take, you know, tens of minutes, 20, 30 minutes, or even I've heard of up to a full day to perform an inspection. The data capture is oftentimes very rudimentary too, right? So apart from just the time to measure at the three different points, there's not a great automated, or oftentimes there isn't a great automated system used to capture that data and to perform the necessary calculations. It's either handwritten and then input into Excel, or even just input into Excel and the calculations are manually made. So, at best, typically I've seen a panel done in 20 or 30 minutes. And really that's probably on the low end of what we typically see. Another challenge is on alignment, right? So you can imagine as you're placing those points, there's very little room for tolerance for positional error. Any sort of positional error is going to have an effect on ultimately of what you're measuring. That's illustrated here. So if you have one sample, if that sample moves to the next one, or to the next, you put the next sample in, and the relative position moves a little bit. In this case, it's exaggerated, but your 3 points that you're measuring aren't going to be in the same location. Traditional methods also can, have an issue with shapes. And oftentimes for shapes like this, you have to define the measurement area, using squares or circles. And then if the shape doesn't match exactly what you trained on or exactly what you created the process for, then your measurement points aren't going to match up. And you're ultimately not going to be able to find defects in the panel either. So I'd like to take a look at what methods are oftentimes used today. So we really break it down into three different categories or three different requirements that are needed. One is your photometric measurement system, so measuring the brightness, the color. Uh, the second option or the second requirement is the character recognition and validation. So, looking for, can we recognize what a character is so we can place our 3 point measurement points in the correct location? Can we verify that a character is placed in the correct location? Can we also look for defects? And then, the fixturing and setup oftentimes is quite a bit more complex when we're starting to incorporate, two different systems with it. And really, right now, under current methods, the two different categories of photometric measurement options and character recognition validation are completely separate. There really isn't a system that integrates both of these. So oftentimes what customers do is for the photometric measurement options, they use either a spectrometer or, a photometer, whether it's something that's built in-house or is something just pulled off the shelf, or they use a colorimeter. And then for the character recognition and validation, a machine vision system with, some sort of OCR or an imaging photometer with in-house OCR algorithms. So when we look at some of the, drawbacks of current methods, so spectrometer, this is a spot meter. As I mentioned earlier, it's just going to measure the luminance and color of a given spot or over a small aperture. So in order to measure 3 points on a character, we're going to have to reposition this mechanically, either move the sample or move the entire measurement system. Uh, there's no OCR defect recognition possible because it's just measuring over a single spot. So this is where your measurement times are going to get very, very long, right? When we start talking about 30 minutes to measure a full panel. Another option is a photometer or a colorimeter. Again, most of the time, these are still spot meters. The difference being that a spectrometer is going to measure the full spectral power distribution of the measurement spot, whereas a photometer or colorimeter is just going to provide the brightness and the color. There are imaging photometers and colorimeters similar to what Radiant offers that I'll talk about in just a minute. But what we see in this space is still very commonly that a spot photometer colorimeter is used. Uh, so, we have a lot of the same inefficiencies that we see with the spectrometer, and that it takes a significant amount of time. Also, if you are using an imaging photometer colorimeter, to date, there is no OCR software that has been available. So even if you're taking an image and getting calibrated data spatially over that image, you still have to have an operator manually place the points in the software, which maybe saves a little bit of time, but it's not going to be a significant time saving advantage compared to a fully integrated OCR plus photometric system. Machine vision systems, can be used. Machine vision systems also oftentimes do have OCR verification, and image processing. It can identify characters. It can look for defects. They are very fast processing times. The big problem here is that it's not measuring luminance or color. Even if you take a machine vision camera and perform a calibration to the source, without optical filters, without factory level calibrations, it's just not going to be accurate enough to measure under a wide range of different panel layouts and different sources. So really, there's no machine vision solution that can accurately measure the light and color to meet the current standards. Uh, Another option, when using either an imaging photometer or machine vision, using in-house OCR algorithms. So basically, an in-house developed solution to identify characters and place the points. Uh, Oftentimes, there's limited functionality, and to be honest, this is a huge resource allocation. We have customers that sometimes have one to even two image process engineers just devoted to the inspection process. So, there can be significant resource savings by looking at a more integrated system. So, kind of highlighting what a traditional method looks like is, as I mentioned, it requires oftentimes at least two pieces of equipment. You have your photometric system for your light and color metrology. You have your machine vision system for looking at defects and looking at the position and orientation of samples. And you have a couple of different software capabilities that are required across either one or both of these systems. And really, what this leads to is inefficiencies. And inefficiencies amount to several different things, right? The cost of the solution, buying two different products, it's more complex, and you have to design more complex fixtures to be able to move a system in and out. And then instead of talking about just one simple measurement, you're now talking about two different measurements. So it is going to add a significant amount of time in the overall inspection process. So I mentioned earlier, sometimes imaging photometers or color emitters, so a system that does acquire image of an entire panel and does meet accuracy requirements in terms of luminance and color. The drawback here is that there's no OCR software. So there's nothing to identify characters for, 3 points. So if you take an image through this, you'd have to have an operator manually place points on each character. So this has been Intel Radiant solution, which we'll touch on later. This has been the problem with imaging photometers and colorimeters.
So what's needed in solution? And really the ideal solution can inspect completely. So it's going to take an image of the entire panel. It's going to identify all of the characters on that panel with OCR, automatically align the 3 points, and it's going to evaluate those points for light, color, and defects according to the specification of the project. The ideal solution is going to inspect effectively. It's going to be one system with minimal equipment and minimal complexity. And it's going to inspect quickly. It's going to have a low takt time. It's going to complete those inspections fast, minimal downtime between inspections, so minimal setup time. And it's automatically going to adjust to multiple panel layouts, character sets, etc. So to address some of these challenges that I just mentioned, I'd now like to introduce the Radiant solution. And really what the Radiant solution is doing is combining those two different elements of the measurement process that I introduced before. So the photometric testing, that you typically get from a spot meter or an imaging photometer like what we're providing, and OCR to handle defect detection, position orientation, and most importantly, the automated process of placing 3 points on the image to take your tests. So outlining the major components as a single camera system that evaluates all characters and shapes in a single image. It is going to measure luminance, including the brightness, the minimum, maximum brightness, light leakage. It's going to measure contrast, chromaticity. It's going to look for defects, the position, orientation, and as I mentioned, character recognition, or that OCR component. So breaking down the solution components, we have the prometric imaging photometer or colorimeter. This is going to handle the imaging and photometric measurement side. We have resolution up to 61 megapixel to capture large panels with sufficient resolution to meet performance requirements. And these systems are factory calibrated, so you're going to get accurate photometric results, including luminance and color. And then on the software side, we have TrueTest software, which is our solution dedicated to automating the visual inspection and measurement process with what we call ACE, or Aerospace Character Evaluation, which is the module devoted specifically to performing the military three-point testing and others according to the standards that we mentioned earlier. What's included in this is dynamic registration of the part. So we're going to automate that process of finding parts rather than relying on a manual process. It's going to recognize characters, and it's going to validate that the correct character is being measured. It's going to perform our luminance and color measurement, including that three-point measurement according to the standards. It's going to calculate uniformity. It's going to look at defect detection. And of course, we can always compare back to a golden sample in terms of looking for patterns across the sample. This solution can also be integrated with external devices. And this is something that always comes up, in a lot of discussions that I and the rest of my team has with customers is, hey, this solution is great, but in order for it to be applicable in our process, it's going to have to interact with other devices, including calibrated light sources for some of those sunlight readability tests. I mentioned earlier how important those are to the overall inspection process. Fixtures for if there is any sort of motion required, or material handling, production management systems, including tracking of results, barcode readers to serialize all of the measurements. We can assign a serial number to the part being measured. This is generally very critical. As well as others, right, that we don't have mentioned here. There is quite flexible device interface, what we call a device interface in our software, that can interact with other components. So I mentioned earlier, the major problem with current solutions is that they take too long. They're too difficult to implement, too difficult to maintain, and overall just not efficient. And what the Radiant solution is doing is it's integrating hardware and software solution for an easy setup. So we're providing a turnkey solution. You don't have to design your own software. Uh, the software and the hardware is going to come together as an integrated package. There's a high tolerance for panel placement and alignment. So, you're not going to have to design incredibly precise fixturing in order to precisely place your components from one sample to the next. We do have high resolution sensors to capture large panels in a single image, or multiple small panels simultaneously. So, whether you have problems currently with low resolution sensors that can't capture an entire panel or a full panel with adequate resolution, we can handle that. And to increase throughput for smaller panels, we have the resolution to be able to measure, let's say, maybe 4 panels in a single capture. High quality hardware ensures speed, precision, and repeatability of luminance and color measurements. So the photometric results that you're going to get are going to be accurate. And we're going to have automatic alignment and dynamic registration. So we're going to take out the very manual process involved with current inspection solutions. And you saw earlier where we didn't have a solution that got green check marks for, light and color or photometric results and efficiency and finding defects. And really what the Radiant solution is doing is meeting all of those requirements. And if there's one thing that I want to stick with you about the Radiant solution, really where the big value in our solution is that we're going to take your traditional inspection solution that maybe takes 30 to 60 minutes, and we're going to be able to do that in a minute or even less, right? So it's very easy to see just with this simple reduction, significant reduction in time, where the value can lie in implementing the Radiant solution in your process. In the next section, I will dive into more details about the TrueTest ACE software and how this inspection is actually performed. So first, there's going to be an initial setup, and we're going to want to define our tolerances for light and color, all those photometric values. And we know that different projects, different customers, different ATPs have different tolerances for the specific photometric or color values. So there's an easy method in software to set these tolerances and save them. We can set tolerances for each measurement point, for the average of the entire characters, and we can set it for specific different POIs. For example, if there's different words have different values. We can also define color coordinates on the chart specific to, in this example, we see NVIS colors. So the test will tell you if it falls inside or outside the defined color. The next step is going to involve character identification. So the software is going to actually automatically, you'll define the area that you want to look for characters, and then the software is going to go through and automatically identify each character. And it's going to do this despite different rotations. So in this example, you can see there's a bounding box surrounding each letter with the the identified letter, as well as the 3 points that we're eventually going to measure placed inside the bounding box. There's also a means in software to look for shapes and icons. And really what this is going to do, in addition to, being able to evaluate the luminance of these shapes and icons, we have the potential to use a golden sample to look for defects in these shapes and icons. So if they're not printed correctly, or if they're the incorrect shape or icon. So that's something else that we can find as well. So now I'd like to overview the inspection process. And first, the software is going to register the FOIs, or the features of interest. So it's going to identify any character that might be a candidate for evaluation. It's going to identify each of those characters and verify that it's the correct character. It's going to apply the 3 standard measurement spots to that character. And then it's going to measure the luminance values against predefined tolerances. So you can see kind of this step-by-step process illustrated on the right, that top image. And of course, any Star Wars fan is going to recognize this phrase. But on the top right, it's identifying each letter. In the second picture, it's actually measuring the luminance. And it's difficult to see on the second picture, but if we look at the zoomed in E, we can see that there's actually a luminance value associated with each one of those points. In this case, green is pass and red is fail. And it's also going to take an average of each of these values, as well as other statistics, and apply that in a report. So I talked a little bit earlier about the difficulty in reporting, right? Manually placing the points on the characters isn't the only challenge that some of our customers are facing. Reporting is a big one too, and it's still done very manually. Sometimes by hand, or manually copying and pasting data into an Excel sheet to perform calculation. And one of the advantages of TrueTest is that we can automate this, right? So there's a lot of flexibility in taking the measured data. Once we have that measured data, we can perform different calculations in software. We can export that to a custom report, or just a raw, CSV or text file for further analysis, or we can even send the data over a different communication, interacting with another software like LabVIEW or Python. So there is a lot of flexibility in the reporting, because we do understand that this is a big component in the overall efficiency of the inspection process. Now I'd like to go over a demo of this process in software that will really overview the inspection steps. So what you're looking at is our TrueTest software with our ACE analysis. So first, I'm going to go ahead and look at the measurement. I'm putting it in false color so you can see where there's bright and dim spots in the image. When I click a run sequence, measurement is going to be acquired. Each character is going to be registered, identified, and then the luminance measured. So you can see that that process took maybe a couple of seconds in total, but I'll walk through. You can see that each character is correctly identified. The luminance is measured, green indicating a pass, red indicating a fail. And as I zoom in on the results here, we can see that the luminance of each point and the average luminance of each character is reported. Okay, so now I'd like to summarize, just what we went over, and really the solution that Radiant is providing to address the inefficiencies in current inspection processes. And on the camera side, what we're offering is the Radiant Prometric Imaging Photometer or colorimeter with high resolution options and tri-stimulus filters for accurate color measurement, accurate luminance and color measurement, as well as the True Test software for automated inspection. And looking a little bit closer at the True Test software, what's included in this: automated test sequencing, precise measurement of luminance, color, and contrast. There's a correlation to human visual perception in the results that we're providing. Multiple analysis can be run from a single image at the same time to really increase that throughput. System integration to production control systems, barcode readers, and more. And the option to set color parameters, including passing and failing by regions on the color chart. And there is a fully functional API and SDK available. Now, looking specific at the different modules specific to address some of the regulations that I mentioned earlier. So we have what we call ACE, Aerospace Character Evaluation. This includes that key element of OCR, right? So automatic character recognition, and then placing 3 measurement points in accordance with these standards. And then VIP, which stands for Visual Inspection Package. This is taking the best of traditional inspection, including looking for defects, looking at the position, orientation of parts, and integrating this into one single software package. So now I'd like to answer the question, why choose Radiant, and overview the points where Radiant is going to add value to your inspection and measurement process. The first is superior hardware. We offer high-resolution photometric imaging systems for rapid and repeatable luminance measurement at all light levels. Radiant has the highest resolution imaging photometer systems on the market. We have fast systems that can keep up with your required throughput, and we have accurate systems through our factory calibrations that are going to provide accurate results to the standards that you're following. On the software side, we offer dynamic registration, pre-programmed test parameters, and multiple analysis performed from a single image. And really what Radiant provides is a turnkey solution that integrates the superior hardware and the software so that you can easily implement a total solution that meets all of your expectations. Color accuracy. Our CIA matched to stimulus filters are going to allow for accurate color measurement when color is required. And on the experience side, Radiant has over 30 years improving quality inspection and product yields for major global brands in consumer electronics, automotive, and certainly the aerospace industry. Service and support, worldwide application engineering staff for support when and where you need it. For our North American customers, we have Prometric cameras are designed, built, and calibrated in our US facility. And for global customers, we do have calibration and manufacturing capabilities overseas in Asia as well. And the last point, customization. And I want to focus a little bit on this because it's really important. And the approach that Radiant takes is really a collaborative approach and a consultative approach. We understand what your inspection challenges are. From that 30 plus years of experience, we do have an understanding of the challenges that you face. And ultimately, we want to provide a solution that can help you improve the process and ultimately deliver better products and better results to your customers. And with that, I would like to open it up to questions.
All right, Chris, thank you for that great presentation. So we are going to move into taking some questions from our audience members at this time. What is the process of setting up the software to inspect a new panel layout?
Yeah, that's a really good question, and it's obviously very important, and it always gets asked, right? Because we understand. I mean, I've been talking the entire presentation about high mix, low volume, right? So that high mix does present a problem when you're constantly introducing new panels. If the process to set something like this up takes a significant amount of time, its value and its usefulness decreases compared to a lot of current methods. So really the driving force behind our development in of this product of True Test Ace and this OCR and automated 3-point measurement system is that it would be easy to set up. That a user, whether it's an engineer or even just a tech on the floor, can bring in a panel, can click a button, and all of the character recognition, the point placement is going to be on automated with little to no interaction from the operator. Uh, with the idea being that even if every single measurement that you're taking is a new panel layout, we're still going to be able to measure in minutes rather than tens of minutes or even hours. So, basically to get down into the nuts and bolts, it's going to depend a little bit on the specific application, but essentially what your tech is going to do is they're going to have all of the camera setup, pre-saved. They're going to bring in a panel, place it, and then you're going to draw a box outlining the areas that you want to inspect, and the rest is going to be taken care of, and you're going to get a report with all of your results. And again, it can vary a little bit depending on what kind of panel we're looking at, but in every single case we understood that it needs to be simple to use. So that's a great question. Thank you.
All right, Chris, thank you so much for that answer. So, next question here. How fast is the inspection?
Yeah, this is another question that is always asked, right? Because when you start evaluating, how can I implement this, you need to understand how fast the inspection can be or what the time that it takes is going to be. Now, it does depend on a couple of factors, and I said in the presentation a minute. That's maybe broadly speaking. We certainly are working in applications where we're measuring in seconds, right? So, depending on how bright the part is and how complex the part is, a typical measurement is going to take a couple seconds at most. If we're looking at maybe night vision products or very dim products, it might take tens of seconds, and then the software analysis on top of that is only going to take a couple of seconds. So, realistically, a minute is probably fairly conservative, but it's still certainly an improvement over 20 or 30 minutes. So we always say, what we'd like to do is you give us the amount of time that you need, or that we have basically, and then from there we can design a solution and work through a solution that will meet those timing requirements to keep up with your required throughput.
Thank you so much for that answer, Chris. For our attendees, just a reminder, if you have a question today, go ahead and enter it into that Q&A window and click submit. All right, Chris, next one in our queue. How large of a panel can be measured?
Yeah, right after the question of how fast is the inspection, how large of a panel can you measure is another great question. And really here, again, depends on factors, but I always say with our high resolution systems, in the past we've been able to accommodate every single new panel, or large panel that we've encountered. And really, how large of a panel you can measure comes down to the required resolution. So we want to make sure we're getting enough camera pixels across each individual illuminated character. So, from the vast majority of panels that we inspect, we're going to take one single measurement. And even for larger panels, we might need to use a 61 megapixel camera, but that's certainly something that we can do because again, our goal is to make this process efficient, and it's not efficient if you're having to stitch together multiple measurements of a single panel. So, really, we do want to provide a hardware solution that is going to meet your most challenging inspection process, being the largest panel, maybe with the smallest illuminated characters.
Great, thank you so much. All right, next one here. Does this system require a dark room for measurement?
And yeah, that's a great question, especially as you start to think about where something like this can be implemented. So generally, we do recommend a brightness controlled environment, right? So something that can eliminate ambient light, because that ambient light will have an effect on your ultimate measurement. So oftentimes, whether it's in a dark lab or even just in a dark box, a black box sometimes is what we call it. But the measurements are taken in a dark environment. Now, I talked earlier about how you know uh, aircraft aren't only flown in the dark, right? And certainly sunlight readability is a critical test to be performed. And so in that case, we'd take measurements in the dark environment with the controlled light. And the reason we don't just rely on ambient light for that is because in that case, it's not controlled, right? So we might be taking measurements under two different conditions, which can yield different results. So it's really all about controlling the factors that might have an effect on the measurements that we're taking. So generally speaking, yes, we do recommend that these measurements are all taken in dark environments for the best results.
All right, Chris, thank you for that answer. So, for all of our attendees, this is going to be the last question today. We are getting close to the top of the hour. If you have any last-minute questions for Chris, feel free to enter them into the Q&A window, click submit, and we will get back to all of you following today's webinar. All right, Chris, so the last one for today, what is the output from the system?
And yeah, this is a great question, especially as you think about the reporting process taking a significant amount of time and how you have to give certain reports to your customers. And there's a lot of flexibility in the Radiant solution. That's what I always tell customers is, we can tailor the output to what you need, or there are tools in the software to tailor the output to what you need. So, we can certainly measure things like lumen or brightness, color, contrast. We can do averages by character, averages by word, and we can take all of that and put it in a package or in a format that your system will accept. Because that is another one of the goals of this process, is to automate the reporting and the output features of the software. And I think that was probably the last question. So I really appreciate everybody's time and attention. If you have more questions, or if we didn't get to your question, then certainly, we will follow up over email, and, happy to set up a call to discuss your specific application. Thank you.
Great. Thank you so much, Chris. So, I want to say a huge thank you to our audience members for being part of this webinar event. Take care, and we will speak with all of you soon.